Hey guys, so day 12 is 8.5, comparing two linear functions. Today's learning goal is I can compare two functions that are represented in different ways. The graphs of two linear functions intersect if the functions have different rate of change. Well, let's reminisce on what the words rate of change mean. Rate of change is simply your slope or your m value. So notice here in your image, the rate of change, if they are different, that means that they intersect. So notice how your rate of changes are different. We're going to talk about later what happens if your rate of changes are the same. That means that your graphs are going to be parallel. So for each city, there is a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. What function has the greatest rate of change? What does that mean in this situation? So we have two questions that we need to answer. The first one is which function has the greatest rate of change? The second question is what does that mean in this situation? Well, let's look here at our first one. At 8 a.m., the temperature was 62 degrees Fahrenheit. Between 8 a.m. and noon, the temperature increased by 3 degrees Fahrenheit per hour. So this increased by 3 degrees Fahrenheit per hour. That tells me that that is my rate of change. It increases over time. So my rate of change is going to be 3 for Eastbury. The next one says T equals 54 plus 2H, where T is the temperature in degrees Fahrenheit and H is the number of hours since 8 a.m. So in this case, we're given an equation. Remember, the value that is attached to the variable is always your slope. So your m value in our case would be 2. The last one, Hilltown, think about your table. It's always the change in y divided by the change in x. So look at your time, which represents your x values, and your temperature is your y. The change from each one for time is 1. The change for each one of the temperatures is 2. So the change in y, which is 2, over the change in x, that is 1. So 2 over 1 is 2. Well, answering our question here, which function has the greatest rate of change? That would be Eastbury. The second part says, what does that mean in this situation? Well, that just means that Eastbury warmed up faster. The functions below describe the temperatures in degrees Fahrenheit on the same day in two different locations. Which function has the greatest rate of change? What does that mean in this situation? So again, we have two questions. The first one says which function has the greatest rate of change? The second question says what does that mean in this situation? So let's answer the first question. Well, let's look at the fun town. At 4 o'clock p.m., the temperature was 70 degrees Fahrenheit. Between 4 o'clock p.m. and 10 p.m., the temperature decreased by 2 degrees Fahrenheit. So decreased by 2 degrees Fahrenheit tells me my rate of change is 2. The next one says T equals 72 minus 2H, where T is the temperature and H is the number of hours since 4 o'clock p.m. Notice your equation here. Your value that is attached to the variable is your slope or your rate of change. So that means in our case m equals -2. I'm sorry, meant to put a negative there for decrease. So this answers my first question. Answers my first question about which one is greater. Well, we can't really say which one is greater. We can say that the temperatures are equal, or sorry, the rate of change are both decreasing which means in this situation, the temperatures in both cities decrease at the same rate. Alright, so here are a rate of changes for 3 temperature functions from the example. If you graph the 3 functions on the same set of axes, what will be true about the lines that represent Eastbury and Hilltown? What will be true about the lines that represent Hilltown and Toperville? Well, again, we have 2 sets of questions. So we need to know what will be true about the lines that represent East Hill, and then what will be true about the lines that represent Hilltown and Toperville. Well, let's look here. Eastbury and Toperville have the same, Hilltown and Toperville have the same rate of change. So that means that these 2 graphs would be parallel. And then the Easterbury and Toperville, these 2 here, would be intersecting. So understand that these graphs will intersect if your slopes are both different. If the slopes are exactly the same, they're going to be parallel. For each city, there is a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. Compare the initial value of the temperature function for the 3 cities. What do the initial values mean in the situation? So remember, your initial values are simply your starting points. So Eastbury's 8 a.m. the temperature was 62 degrees. That tells me right there that that is my initial value. So my B value is 62 degrees. Topersville, T equals 54 plus 2H. The 54, remember, it stands alone. So B equals 54. Hilltown, the Hilltown portion with the table, be careful. Notice how everything is starting at 8 a.m. So we want to look at the temperature and time at 8 a.m. So at 8 a.m., we're at 62 degrees Fahrenheit. So the question says, what do the initial values mean in this situation? Well, we can see here that we have 2 cities that are 62 degrees, and we have 1 city that's 54 degrees. We can subtract these 2 values, and we get 12 degrees as our difference. That tells me that Eastbury and Hilltown are warmer than Toperville. So Eastbury and Hilltown are warmer at 8 a.m. Sorry guys, I have a typo there. This should definitely be 8. Ms. Jones can't subtract today. Alright, these functions describe the temperature in degrees Fahrenheit and on the same day in 2 different locations. Compare the initial values of the function. What can you conclude in this situation? Well, first again, let's identify what we're asking. What can you conclude about the situations? So let's look at Funtown. At 4 p.m., the temperature was 70 degrees Fahrenheit. Between 4 a.m. and 10 a.m., the temperatures decreased. Well, it tells me that the temperature at 4 a.m. was 70 degrees, so my B value, my initial starting point, is 70 degrees. Schuster, it gives me an equation that says T equals 72 minus 2H. Again, remember your B value stands alone. So in your equation, the temperature is going to be 72 degrees if you're starting. So what can you conclude here? Basically just means that Schuster is warmer at 4 p.m. That's all that really means. scroll down so you can see it. All right, so comparing functions. Just a reminder, different rates of change, different initial values. So notice here that you have different rates of change, meaning you have different slopes, but you also have different initial values. So their starting points are different. The next one says different rates of change and the same initial value. Notice here that they intersect a little bit closer, a little clearer at the same initial value. And then the last one, same rate of change, different initial value, means that they're parallel lines. So notice here, they're parallel if the slopes are the same. Alright, so guys, please write down any questions that you may have. This lesson was definitely longer and definitely a little harder. See you guys tomorrow.